All right, welcome back. Now let's get into an arena tutorial where we'll step through building a relatively complex model so that hopefully you feel more comfortable moving around in these arena modules and see how they work. So this is basically going to be based on, I happen to have the 6th edition of the textbook here. This is if you flip to chapter 4, which in my textbook is page 121. But it may be a different page in some of your textbooks. We're focusing on section 4.1, which is an electronic assembly and test system. So the basic overview of what we're building, so this is not an arena flowchart, this is just a flowchart of how things are working, is imagine if you've got an electronic assembly and test system like this one. So you've got arrivals of parts that come in. So we have a part A and a part B. Notice that part A, those parts arrive with exponentially distributed inter-arrival times with an average of 5. So that's like, say, 5 minutes or 5 seconds or whatever the time unit is for this one. And then part B, it's got these exponentially, it's got parts that arrive in batches of 4, and those batches are separated by an average of 30 time units from an exponential distribution. So 2 types of parts arrive at different rates, and one is in batches of 4. Those different part types have different preparation processes that they go through. So part A gets prepped, and the prep time for part A comes from a triangular distribution where no part will take less than 1 time unit to prep, nor more than 8 time units to prep, but they'll take a mode of 4 time units to prep, and that whole thing will be a distribution that looks like a triangle with from 1 to 4 to 8. And then part B also has a triangular distribution, but it doesn't take any less than 3 minutes or any more than 10 time units, and has a mode of 5 time units. And so the idea here is that maybe that's the best you could model. People just said that, well, it's never going to take less than this or more than this, but it usually takes around this amount of time. And so you decided to model that with a triangular distribution. But you basically captured this idea that part A and part B could take similar amounts of time, but generally part B takes a little longer to set up. But both parts come together and they go through a sealer process. And so in this process, part A is going to take a certain distribution of time, which again has been specified with a triangular distribution, no less than 1 time unit, no more than 4 time units, with a mode of 3 time units. But part B, it apparently, with its process that it goes through, even though it's going through a sealer, when the sealer is working on part B, it has a totally different distribution, and it comes from a Weibull distribution, and that Weibull distribution has these 2 parameters here. So if you're not familiar with a Weibull distribution, and we'll talk about a Weibull distribution in class, a Weibull distribution is like an exponential distribution with an additional shape parameter. So you can make, whereas an exponential distribution looks like a ski slope, a Weibull distribution actually has a hump in the middle, or can be made to have a hump in the middle, kind of similar to a triangular distribution. So basically what they're saying here is, although part A will never take more than 4 time units, part B actually could take a very, very long amount of time, although it'd be very rare. But we don't have an upper bound on how long part B will take to go through the sealer. All right, then 9% of them end up getting directed through a rework. And so basically there's something wrong and they have to go through some sort of rework. And that rework has just been modeled as an exponential distribution with mean of 45 time units. And then of those, 80% the rework worked out. So they're salvaged and they're shipped. But 20% of them, they just can't be reworked, and so they get scrapped. Otherwise, if they weren't in that 9% that went into rework, the other ones just get shipped off. So that's what we're trying to model here, this idea that we've got these parts that come together, a fraction get reworked, and then a fraction of those get shipped. And we want to then build that using actual modules in Arena. All right, so let's get started on this. So I'm going to open up Arena on my side. So when you open up Arena, if you have the student version like this, you're going to get this warning here that you have the student version. Don't worry about that. Just hit OK. And you may not have all the panels that I have here. For now, just go onto the basic process panel right here and drag on to create modules and drag on to, so I'm not going to do all of this in front of you. I'm going to end up pausing and have you do it. But basically, we're dragging on 2 create modules, 2 assign modules, 2 process modules, 2 decide modules, 4 process modules, 2 decide modules, 3 record modules, and 3 dispose modules. And you can find all of those here under basic process. And then connect them using the connect tool. So I'm going to pull up, I'm going to see here on the diagram, notice that I have a create module followed by an assign module. So I'm going to do that here. I'm going to grab an assign module, which is down here. I'm going to drag it over here. And I might then grab this wiring tool and I'll select this port and then have them wired up. So take about 10 minutes now. So you can go ahead and pause the simulation. I'm going to pause the recording and work with you and construct this diagram that you see here. And then once you're done wiring them up, then hit play again and we'll go into what we do to actually start configuring these. All right, so we're back. Hope everybody had success wiring those things up. You may have noticed that if you accidentally drew a new wire, a wire that you didn't want, in order to delete that wire, one way, or sort of an easy way to do that, is to right click on the wire and then go down to delete. So that's one way to do it. So, as an example, if I wanted to delete this wire, let's say it was incorrect, I can right click on it and go down to delete, then the wire is gone. And I can put my new wire back, which happens to be the same as the old wire. Now, if for some reason you ended up drawing, getting lost in your model, and you want to get the model back, if you hit the asterisk, so hit Shift 8, then it'll rezoom the window so that it just sort of snaps around all of your model. So that's another little tip for moving around inside Arena. So there we go. We've drawn our model. So let's see what's next. All right, so now that we have the basic structure of the system, we need to configure the inputs for all of these inter-arrival times and process times and so on. And so we are going to go and edit the create module. And so you'll go into each of these create modules. So if I go into my Arena here, and if I double click on the create module, I end up getting a box that looks like this one. And we want to change the names of these create modules, like Part A arrive. And then the entity types, we're going to call this Part A. And whenever I type an entity type that it has never seen before, it then automatically creates a new entity of that type. And then I can configure those entities later under this the entities data module. All right, then in the timing, we'll go down here and we'll change the distributions, like an exponential with 5 minutes in between each arrival. And how many arrivals? Then for A, we'll just say we want 1 arrival. And we'll leave the default, allow an infinite number, and we'll say the first one happens at 0. So we can click OK there, and we've got Part A arrive. Now if I go back here, it wants me to also do the same thing for Part B. And I mentioned that if you need extra help for this, if we go to looking down here, if we flip through section 411, and then now we're in section 412 under building the model, then displays 4.1, which is, I believe, that one there, and 4.2 have got these information about these things in them. And so you can just see in like display 4.1, you've got this same box that we're looking at, and then underneath it there's a table which tells you how to configure the box for Part A. And for display 2, or display 4.2, there's just this table at the top here, and that tells you how to configure it for Part B. So go ahead and take 5 minutes and make sure you then configure your create modules as they say in 4.1 and 4.2, which basically, again, just to summarize out of the book, for A, we want them to have, it looks like 5 minutes in between every arrival of Part A. And then for Part B, we want 30 minutes in between every arrival, but we want 4 entities to arrive every arrival. So they arrive in batches of 4. So I'm going to pause and let you do that, and then hit play again when you're ready to continue. All right, so now that our entities are created, they're arriving, then we need to do what's next here. We need to adjust these assigns. So let's go to that part here. So in the assign module, we are going to assign them. We're going to keep track of when they arrive, and we are going to keep track of how much time they are going to spend later in the sealer. So it's a little weird. Before we've even hit the sealer, we are going to assign them an attribute, which effectively the sealer just reads off in the model and then spends that amount of time. So although in real life, you arrive at the sealer and then your sort of physical properties into determining how much time you spend in the sealer, in the model, it's almost as if we know how much time each one of them is going to spend ahead of time, and the sealer just reads that off and waits for that amount of time. So we do that by going into, say, so if I go back into Arena and I go to my assign block, this is when part A will go through here, and I'll need to add 2 attributes. And so I can add an attribute called, so it needs to be selected attribute and attribute name sealer time. And if I remember for type A, for the part A sealer time, it was a triangular distribution 1, 3, 4. So that's no less than 1, a mode of 3, no more than 4. And so I can just type that in here, trio 1, 3, 4. Now, I can always right click on this and go to build expression. And if I go under build expression under random distributions, if I click on triangular, I can say minimum value 1, most likely 3, maximum value 4, and it creates the expression for me down there. And if I were to hit OK, it then brings it back here. So I can always use that build expression. And then I'm going to change the name of this based on what the book suggests, assign part A sealer and arrive time. So you probably won't get that detailed in your names for your models, but they're kind of making it very clear here in this example. All right, now I need to assign the arrival time. So this is, again, I'm going to make this an attribute so that it's stamped onto every entity. And I now want to make it the current time. So I just want to remember for this entity, when did they arrive? This is just like in a hand simulation where we associated an arrival time with each entity so that later on we could calculate how long they've been in the system. Now, let's say I don't remember what the expression is for the current time. I can right click, go to build expression. I can look down through here and I say, well, maybe that's a date and time function. So I'll bring that out. And then I can look down through here and see current simulation time, T now. That's what I want, the current simulation time. So it assigns T now there. So now I've done that for part A. I need to do that for part B. And as we see here, if we look down at display 4.3 in the book, it has the same thing up that we have right now. And display 4.4, which is just the table on the next page, that gives you the values that you need for A and B. And so go ahead and take a look at displays 4.3 and 4.4 in your book and configure your 2 assign blocks according to those, like we just did here. And then I'll come back after that. All right, so we're back. So the next step, so we just did the assign modules. So the next step is we need to then edit these process modules. So if we look back at our arena, this process 1 and process 2. So we can go into, say, process 1 here, and we want to change process 1 so that it represents the PrepA process. So I'm going to add PrepA process. Now if we look back through here, what we need to do is configure this to be a so-called seize delay release. So if I go into the action here, the default is just a delay. A delay just waits. It just holds on to an entity for a certain amount of time, but it doesn't actually use up any resources while it's waiting. So it just delays the entity. Now if I change this to seize delay release, then it opens up this other window here, this other box here, that allows me to associate a resource that this entity needs before it lets go of this process. So if we look back up here, I need to create a resource called a PrepA resource. So it is going to be a resource name PrepA quantity 1. So this is saying that when the entity moves through this process, it is going to try to reserve one element of the PrepA resource. And if it's not available, well, we'll see what happens if it's not available. So I can then hit add, and I can call this the PrepA resource, and 1 unit to seize or release, and it's done. And if I now, I'm going to go back in here in a second, but now that I've changed this to a seize delay release, notice that the process has this blue line across the top. That, and even has a little pop-up. It says it's a queue. So, and it has an identifier, PrepA process.queue. Because this is a seize, then that means that some part A's may arrive and there are no PrepA processes available to seize. And so they will have to wait in the queue. And so creating a seize inside one of these processes here implicitly creates a queue as well. And then so that's one of the ways you get queues to show up in Arena. Okay, now if I look at the delay type parameters, we've modeled the PrepA process as another triangular distribution with minimum 1, most likely 4, mode 4, maximum 8. And so I am going to configure this in that way as well. So this is minutes, triangular distribution, 1, 4, 8. Now we notice that back here it has allocation value added. So this is getting a little more advanced, but basically you can tell Arena when it does its bookkeeping where to put this delay time or where to put this activity time. So this is value added because this is time that we actually need the part to go through. It's good time. Now we can have non-value added time, which might be time you spend waiting in a queue. You know, that might be wait time, or time you spend transferring between things. That would be transfer time. So basically these are different counters for adding up value. Now, so we're not worried about that here, but this allows us, just like in Quicken or something like that, or in different accounting applications, it allows us to tag different processes so that we can account for them later and split them out by these tags. So for now, we're just going to leave the default, this value added allocation. And I think that's all we have to do for this first process here. I think I covered everything for the PrepA process, but if we look back in the book, under display 4.5, it has the PrepA process listed there, the same stuff we just went through. If I flip to display 4.6, it talks about the sealer process, and display 4.6 down here, the sealer process. And there is a third process, that the PrepB process, which it describes in the text before that display 4.6. So what I want you to do is to go into the book and look at display 4.5, display 4.6, and the text in between them, so that surrounding text, to figure out how to edit these 3 processes. So in Arena here, we're editing the PrepA process, the PrepB process, and the sealer process. So take about 10 minutes, go ahead and do that, and then we'll come back and we'll move on with this model. All right, so if everything worked out okay, and we go back into your Arena module here, we should find the PrepA process the way we left it, triangular minutes, 148. Now the PrepB process, make sure you set your units here to minutes. The default, I think, is hours, and so leave it, make sure it's here minutes, and then this 3, 5, 10. Now, those of you who did the sealer process may have noticed the delay type was expression. I've left my expression unpopulated now, so we can talk about this a little bit. So they say to put in the expression sealer time. Now let's unpack that a little bit. If I go and I say right-click on this and go to Build Expression, I can go under basic process variables. It has attribute. And if I click on attribute, I can say value. And then under attribute name, these are all of the attributes that are currently defined in the model. And sealer time is available there. So I can just select it and hit OK, and it fills that in with sealer time. Now I could have just typed it in as well. But the reason I showed you that is I'm just emphasizing that an entity is going to come through with this attribute stamped to the entity that has been set by a random distribution earlier in the model. And now it is going to be read out by this process, and that's how long it's going to stay in the sealer. And so this sealer time was drawn from one distribution for part A, from a different distribution for parts of type part B, and here the process is agnostic to which type of part, because both parts have this sealer time attribute. It just reads out a number. That sealer time is going to be 5, or it's going to be 3.2, or it's going to be pi. But it's just going to be a number. That number was drawn earlier in the model when that assign block happened, right after the create blocks. And so that's what ends up setting this value. That'll be read out here, and that's how long it'll wait. All right, so now we've set up our 3 processes, so we're kind of in the home stretch here. It really gets, it's going to get easier here. We only have one more process to worry about, a couple decide blocks and records. All right, so the next decide module here. So this is, we had to decide, we need to choose the fraction that failed the sealer inspection. So let's go to that decide block. And they want us to name it failed sealer inspection. And we want 9% to meet this condition. So we're going to leave this as a two-way by chance. Notice there's two-way by condition, in-way by chance, so more than 2 ways, and in-way by condition. These by condition, you end up setting these deterministic conditions, let's say based on attributes, and these by chance, you end up putting in probabilities. So we're going to do the 2-way by chance here. And in the true case, it's really tiny, but it says true here. Those are the ones that fail. And so they'll have to go through the rework process. And these ones here, these go straight to shipping because they did not fail. So that's the 91% that did not fail. All right, so that's double click on decide, fill in failed sealer inspection, do the % true equal to 9. And if you need extra help with that or extra context, then check out display 4.7, and that's just what we did right there. All right, so if you want, go ahead and pause. Otherwise, let's move on. All right, so the rest of it, I want you to just go down through displays 4.8, 4.9, 4.10, 4.11, and the surrounding text, and just complete the model. So I want you to configure the rework process, configure that decide module, and then configure those record modules, which will be used in order to take statistics about the different types of parts, the parts that end up being scrapped, the parts that were salvaged, or the parts that were shipped without reworking. And then those dispose modules, you don't really do much configuration with those. So go ahead and finish that out, and I'll go and do that as well, and we'll come back and we'll talk about anything interesting that came up as we did it, and then we'll round out this video. All right, hopefully that wasn't too terrible, filling out the rest of that model. Let's take a look at a couple of things of note. So in the rework process, notice that they had you do an expression type minutes, and the expression was an expo 45. They were just showing you that there's ways in which you can enter these expressions for these distributions, just like triangular, Weibull, etc. Now, if you look underneath here, there's constant, normal, triangular, uniform expression here. So this triangular is what we've been using. If we would have gone under the build expression and gone to random distributions, triangular, then we could have built up an expression for a triangular, just like under exponential, we can build an expression for exponential. So basically they give you common expression types here, constant, normal, triangular, uniform, but all of these are also available as expressions. And so just like with exponential, they don't give us it as a common one for this type of input, although they do for create. But even if it's not in the delays here, then you can still go to expression and then build one up. And as we'll learn, sometimes the expressions we need are going to be more complicated. So we might actually need to implement an inverse transform sampling or something like that, in which case you can put the formula there for your inverse transform sampling or random variate generator, and then that will end up being the expression. That'll be sort of a long arithmetic expression involving a uniform random variable and so on. So maybe not even as simple as this expo 45. Other things I wanted to point out. So under these record modules, under static definitions, it had us choose a time interval and then an attribute name, and it had it put it into a tally. What that's basically going to do is every time an entity goes through there, it's going to ask that entity what its arrival time was, this arrive time attribute, which we stamped it with initially. It's going to then, as they say here, records the difference between the current time and the time-stamped value stored in the attribute name. So then it's going to see what the current simulation time is, t now, and subtract off that arrive time attribute. And then whatever the difference is, it's going to store in a list. And that list is named record scrapped parts. And if we were to look at that list, then we could take like the average of that list, and that would tell us the average time that, say, a scrapped part spent in the system. And that's the same thing that it did with these others as well. All right, so what's next? Well, we've now built the model. Now we need to set up the run parameters. So if you go back to Arena here, and it might be a good time to save. So you can do File and save this somewhere. It'll pop up a box asking you where you want to save it. And then you can go to Run, Setup, and that's where you get things like these project parameters and replication parameters. And so if we look under Display 412, they've got the project parameters, and then the display next to it, 413, has got the replication parameters, and I've tried to reproduce those here. So so under project parameters, I'm going to just put in the title, electronic assembly and test, analyst name, William Seeley Gossett, which, if you don't recognize, the reference there is that is student from Student's T-Test. He was working at Guinness Brewery at the time. He wanted to publish the T-Test. Guinness said they couldn't have him publish under his name for intellectual property reasons, but he could publish under a pseudonym, and so he used the name Student. So Student's T-Test, it's not called Student because we only have students deal with it. It's called Student because that's the name Gossett used as a pen name when he published the T-Test. So that's what why they picked that particular name there. And then down here, we are going to have it collect statistics on the entities, the resources, the queues, and the processes. So it just automatically does some stats collection even without us using those record modules, and that's what we're asking it to do. So then I can move over to the run replication parameters. And I want to run one replication, but I'll run a replication of length 32 hours. My time units are going to be hours. I have 24 hours per day. So what the time units on the right-hand side here refer to the things on the left. So 32 hours, 0 hours. But the base time units, let's go ahead and make minutes, because that's what we specified everything else in. So it's under minutes there. So I can hit apply there. And let's make sure that there's no other replication parameters I need to worry about here. I think I've got all of them. Yeah. Now, there can be times where you set a replication length very long, even infinite, and then you tell it to terminate on a terminating condition. And this is another one of those where you can build an expression. So basically, whenever this condition turns true, it stops the simulation. So here we're fixing the time and having it run for a particular time, but we could have also have it only, terminate once a particular performance metric was raised, or once a certain number of entities were drawn, or something along those lines. But we're just going to do it based on time for this sim. So all right, make sure that you've done all of that, and maybe take a look at the surrounding text. You can hit a pause here, and we'll come back and finish up with this model. All right, we only have 2 more slides and then we're done with this model. And so the last slide, this is easy. We are just going to visualize these 2 entity types differently so that when they run, we can tell what type is part A and what type is part B quickly as we're looking at them. So if we go back into Arena and we scroll down under the basic process to the data modules down here, we find all these data modules. So if I click on resource, for example, I see all the resources we created. Remember, if I double clicked on create, I end up getting this part A entity type, I'm sorry, resources. So if I click on the PrepA process, remember we created a resource called PrepA, and whenever an entity went through this process, it needed to seize 1 unit of PrepA. Well, it then created under resource a PrepA resource that by default has a fixed capacity of 1. So I can actually change the capacity so that I could run multiple PrepAs in parallel, for example. By default, we just leave 1 resource available for PrepA, 1 for PrepB, and 1 for the sealer. So nothing, PrepA and B can happen in parallel, but they all have to wait on the sealer, for example. And 2 PrepAs can't happen in parallel, and 2 PrepBs can't happen in parallel. Now the data module we're really focusing on here, and there's the attribute 1 over there, which has our 2 attributes, is the entity data module. And under there I can see my part A entity, and its initial picture is picture.report. Now what I want to do is I want to scroll down through there and change the part A picture to picture.blueball and the part B picture to picture.redball. And this will allow it so that when the simulation runs, then we'll actually be able to visualize these parts as they come through. And so if they were both, a picture.blueball, then as they come to the sealer, we won't be able to tell which one's part A and part B. So this just helps in kind of debugging and making sure our model is working correctly. And it can also be insightful seeing the way they queue up. So I'm going to scroll down through here, and I think, what did I say? A is the blue ball. All right, so I'll go picture and find the blue ball up here. Blue ball. And then this one here, I think I can actually get away with actually typing red ball. Hopefully, let's see. All right, so that's what we did here. We clicked on entity. So if these aren't showing up for you down here, make sure you click on entity. And then be careful, because if you end up clicking on one of these modules, it's going to change the spreadsheet view down here, even though it looks like entity selected. So you have to re-click on entity here. So make sure you're focused on entity, and then you can change these initial pictures. All right, so now we're ready to run it. So that's all we're talking about here. So there are these buttons up at the top of Arena here. So if I go back into Arena, right here, then at the top I've got play, step, which goes from event to event in the event calendar, fast forward, which turns off the visualization and just runs it to the end of whatever our run setup said, and then start over, which just resets the simulation back to the start. When I play it, pause will also become available, which will just stop it in its tracks and then allow us to pick back up where we started. And then stop, or end, which is actually similar to reset, but it sort of keeps the stats from the previous run. So, but allows us to go and edit the module again, or edit the model again. So if I hit play, things go really fast. It's hard for me to see much at all. So I can drag this down here so that now things go much more slowly. And I can hit pause, like I did there, and I can see this poor red ball is waiting for the PrepB process. And if I see there's 2 underneath the PrepB process, that means that there is one entity in PrepB and the other entity waiting, and that's why it's sitting there waiting. And if I were to double click on that entity while paused, then I get to view all sorts of attributes of that. So I can tell all of these different things that come for free, and then under user defined, I can see its arrive time and its sealer time. So like I said, I just get these real numbers. And so this arrive time was just drawn randomly from that distribution that we put back here in the assign block. This sealer time was drawn randomly from the distribution we put back here in this assign block. And those will then, the arrive time will be used in order to calculate statistics when things leave. And the other one, the sealer time, will be used when it finally does hit the sealer process. That's how long the sealer will take. So if I hit play again, then I can watch this process keep going. Now we see the blue and all that. So if I want to, I can speed it up a little bit. And I can speed it even faster to the point where it's not, I can start seeing cues and things, but it's kind of difficult to see. And eventually this thing will end up ending on its own, but if I'm tired of the visualization, I can hit fast forward and then it finishes and asks me if I want to see the results. So that's all I'm asking you to do here. Play through, hit the fast forward, and then if you'd like, then you might also want to look at the text to see about how to do all these different batch runs and things. But for now, fast forward is a good way to get to the end. And then when it says, would you like to see results, if I hit yes, then it's going to bring up this reports here, and this opens up in Crystal Reports. And unfortunately, in my system here, because of how VMware is set up, my report has failed. And so this is kind of catastrophic for this video. But hopefully in your system, then you'll actually be able to view those Crystal reports and see things like this, which is just before section 4.2. And so if you look at figure 4.5, where it says the Q section of category overview report in model 4.1, then you can see there that it has stats on like PrepA process.q, the average time entities spend in that queue, the maximum time entities spent in that queue, the minimum time entities spent in that queue, and so on. And so here in this reports view, that's where you can end up finding that info. For me, it turns out that the reason this happens has something to do with how I've set up my file system inside VMware, and so I need to go and fix that. But for the purpose of this lab, we don't need to really worry about that for the moment. All right, so that is the basics of how to get a model built inside Arena. So I'm going to stop this video now, and the next video will be the actual lab exercises we expect you to do for this lab.